Let's talk about a general purpose tree building algorithm called CART. CART stands for Classification and Regression Trees, and it constructs a binary tree which is made of yes-no splits just like before. Assume that we have a data matrix xij. In this matrix, I is the particular data point and j is the particular feature. Assume we also have this label vector y with yi's. In this case, we can have a categorical y or a numerical y. So we can have this classification or regression problem. Let's also assume that we have our impurity measure according to this problem. In this algorithm, we will loop over every feature j, and we will split our data points depending on the value that it takes. So we will use this xij as our split condition. We will split the data set into two parts, being left and right. For the left data points, we will use this notation, xl, yl, and we will use this condition for that. For the right data points, we will have xr, yr, and again, that will take the remaining condition, which is going to be this. We will also let these nodes have these sizes, nl and nr, and overall, we will try to keep track of the split that maximizes the average decrease in the impurity, or we will look for the split that will maximize our information gain. And that's really easy to calculate, because just like before, we will look at the impurity before the split, which is the impurity in the parent node. Then we will calculate the impurity after the split, which is going to be this weighted sum of the impurities of the left child node and the right child node. And over here, you can also see this weighted sum. As you see, we are using this number of points in the left and the right child nodes, and we use this summation at the end. And overall, this is going to give us the weights for the left child node and the right child node, and we are using that in the impurities. Overall, as I said, we are going to look for the split that will maximize our information gain. Then we will find that. After we find that, we will recursively pass the left and right data sets to the child nodes, and we will keep repeating this process. If we have some stopping criteria, if that's met, in this case, we need to decide what to return. In this case, we will have our leaf nodes. So these leaf nodes can have our best guess. It can be the average or the most common class. Overall, this is the CART algorithm. Let's also talk about a trick here. As I said before, we are using all the possible points in this split condition. So we are trying a lot of candidates here actually. One little trick that we can do in this selection, especially with the numerical features, is to sort our data points. Because when we do that, things will be easier. After we sort the data points, what will change in terms of the impurity calculation is that we will just switch one data point from right to left. So we'll have the data points going from this to this, and that won't cost us too much compared to what we would have in the beginning. For our predictions, we just need to send our data points to the particular data point down the branches, and once we hit a leaf, we return our desired value. It can be for classification, the class. For regression, it can be the average value. Overall, we can also make some soft decisions. For example, we can have some soft decisions like 80% cat, 20% dog, rather than these hard decisions like this is cat.